In this video I want to talk about basic tube circuits, or how to connect a tube or vacuum tube or valve. This is just a very basic beginner's video. And first of all I want to compare the tube with a transistor. As you may know, on a transistor you have three connections: collector, emitter and base. And applying a positive voltage on base on an NPN transistor will reduce the resistance between collector and emitter. I've got a small circuit here. I have a transistor and an LED, or a LED, and what I'm going to do is I'm going to plug in a 100k resistor from base to plus, or well, at least even if I'm touching it, you can see that the LED already lights up. It's not that easy with one hand. So now I have applied, or I'm attempting, it doesn't really hold, I'm attempting to apply 100k. So I successfully applied the 100k from base to plus, and the LED is lit, as you can see. And this is a transistor circuit. So if you apply a positive voltage from base, the resistance from emitter to collector will go down. It closes the circuit and the LED goes on. It's a little bit more tricky on a vacuum tube or valve than it is on a LED, but therefore you have the nice glowing on the vacuum tube. Anyway, so if you would compare the transistor with a vacuum tube, you could say that the collector equals the anode, the base equals the grid, and the cathode equals the emitter. But there is a problem. Meanwhile, you have just one base on a transistor, you suddenly have three grids on a tube. And if you are a beginner with tube electronics, as I once was, until Iflose, another YouTuber, you should check out his channel, gave me a good explanation how these tubes work, I was not really having any clue how to connect the grids. Because if you would take the multimeter and measure from a transistor's base to ground, you would of course measure 0 volts. But on a tube there are some volts, some like 0.5, 0.6 volts coming out from the grids and can be measured to ground. And so, how do you connect the tube to make the LED light up? I have got the same circuit here. I have the LED between my 75 volt supply, which comes from the switch mode power supply, and between ground I have a 10k resistor to reduce the current. Also, there's another reason why I'm having this resistor here between cathode and ground. So first of all, some tubes are having two grids, some are even just having one grid, but lots of tubes are having three grids. And the first thing that you want to learn is that there's a third grid, which you often can more or less ignore. In some tubes they have a third grid, but it's internally connected to cathode or to ground. So if you connect the third grid to ground, you will have lots of linearity in your tube or on the tube circuit. This is what you want to do if you want to build an amplifier or receiver. If you connect the third grid to anode, you will have more power because there is just more space and the tube can handle more current. So, what do you want to do to get this tube conductive? Well, if you want to get it conductive, you want to get the second grid to plus. Like on a transistor, if you connect the second grid, which is grid 2, to plus, the resistance between anode and cathode will reduce. Also, do not forget to connect the filament on the tube, because otherwise it won't work. So what I'm going to do now is I'm going to connect the grid, which I have to look up which one it is. It's pin 8. So I will connect pin 8 to a power supply, to the plus UB, via a resistor to get the tube conductive. And as you can see, the LED now lights up. If I would disconnect the filament, the LED would go darker and completely go out. So always have your filament connected. But still we are having three grids left. If you would now attempt to build a circuit, for example an oscillator, what probably would happen is that the oscillator would start working. I have had that when I was experimenting with tubes and wasn't experienced. The oscillator starts working, but suddenly it just shuts down itself. And that's because the grids are charging each other, or better, they are charging up, and then it won't work. So you want to keep grid 3 and grid 1 busy. So on a tube, depending on which grid it has more influence on the current flow. The most influence is done by grid 1. then comes grid 2, and then comes grid 3. But still you can block the conductiveness of the tube with the other grids. So what you usually want to do is, if you leave grid 1 open, I mean do not connect it, or even connect it to plus via a resistor, which is usually not the way you are doing it, but you can connect it to plus, then the tube will get even more conductive, or the resistance between anode and cathode will get even lower. If you go ahead and connect the third grid to plus, eventually it will block the conductivity from anode, because another trick with tubes is you can go ahead and use, for example, grid 1 as grid and grid 2 as anode. And if I would, for example, now connect grid 3 to plus, which I'm doing now, just let me have a look. I've written that down on my arm. Okay, pin 9 is grid 3. So if I would now connect grid 3 to plus, the LED actually should go off. Let's see if it does that. And if not, I'm blaming myself a little bit. Okay, well, it's getting brighter. Okay, I'm blaming myself. I'm explaining tubes to you and don't even understand it very well myself, but this is what I know about this. Well, I thought it would now, that now the LED would go out, because then the current wouldn't flow over the LED, it would rather flow over grid 3, but eventually it's because of the low impedance. These are 100K resistors and the LED is maybe having 500 ohms, I don't know. Okay, let's continue with what I know. So if you want to get the tube not so much conductive, you want to have grid 1 more negative voltage than cathode. And one way to do this is to make a high resistor between 0 volts and cathode, and then you make a low resistor between grid 1 and 0 volts. Here I once again have my 100K resistor, which I will now connect from grid 1, which is pin 2, I remember that, to ground, and that should dim the LED. And as you can see, doing this, well, of course, if I get it on camera, does dim the LED. So here we go, unplugging it. And as you can also see, when I'm touching it, I can align the brightness from the LED. But even if I would add a wire bridge here, eventually it will happen, especially on tubes that have the grid connected internally to the heater, that the LED does not completely go out. This is a tube with indirect heating. That means the filament and the cathode is not connected to each other. But some tubes, especially battery tubes, are having the filament and the cathode connected to the same connection. And so you cannot place a resistor, which is this one, you cannot place a resistor between cathode and 0 volts. And so you cannot get the cathode more negative than 0 volts. Which means even on these battery tubes where the filament and the cathode is connected to each other, even on these tubes, even if you short the grid directly to ground, you will not be able to completely get the LED to turn off. And one thing that they are doing there is they are using a so-called negative supply voltage. I have a 9 volt battery here, and I've connected the plus. As you can see, I've connected the plus to the minus from my circuit. So I've connected the plus from the 9 volt battery here on 0 volts. And what I'm now able to do is, I can supply, related to 0 volts, a negative minus voltage on the grid, which should make the tube not conductive anymore. So this is the minus pin from the battery. And if I'm connecting it to grid, you can see, I'll do that again, you can see that it will turn off the LED. So here I'm minus 9 volts, and as soon as I connect it to the grid, the LED completely goes off. If I now charge the grid again, oh, this was the wrong one. Well, it's 75 volts, I touch it, but you shouldn't do. So if I, well, okay, this tube is giving me lots of questions instead of answering questions. What my knowledge is, Eflose told me, if I add a positive voltage to grid 1, the tube is getting more conductive. So it actually should brighten the LED instead of lowering its brightness. And the problem is with grid 1, if you add too much supply voltage, then the tube will get broken, because physically, I don't know exactly how this works, but physically there is a very short distance, like two metal parts. There's a very short distance between grid 1 and cathode, and if you add too much supply voltage, it can be only 40 or 50 volts, then the tube will arc internally and will get destroyed. So this is why you not add a B plus voltage on grid 1. Adding B plus on grid 2 is okay, as it's okay on grid 3, but don't add it on grid 1. I think I even had that when I was experimenting with tubes and didn't know stuff. I just bridged grid 1 directly to B plus, and I saw a spark in the tube, and I even heard a thing every time I did that. But the tube survived, but still you shouldn't do it. So I don't know why it's not behaving as I wanted to behave. Obviously lots of stuff I still don't know, but I just wanted to make a video and try to explain tubes to you. Once again, I'm bridging plus from the 75 volt capacitor to grid 1. Why is the LED going out? Actually, it should get brighter. But okay, so that was my attempt to give you a basic explanation about tubes. One thing you can definitely run sure if you are into tubes is connect grid 3 to anode. Use grid 2 to control. For example, you can use a potentiometer there. And G1, well, bridging it to ground. Let's try again. Bridging it to ground does not change anything here. So you can bridge it to ground if you want. And yeah. So why should you use tubes? Well, in my personal opinion, some people say that they are having a special sound. So if you want to use it as headphone amplifier, they can provide a special sound which a transistor amp cannot really provide, except you're having some sound processing going on. Tubes are very good for building transmitters. So you can build an oscillator with one tube and directly connect it to the final amp, and you won't have frequency modulation. So they're very good for building transmitters. And well, for the optical aspect, as you can see, there is this glowing thingy inside, which is optical very nice. But I personally prefer transistors because you have a very clear state. B plus via a resistor to base makes the transistor conductive and not this mess with these grids, and it must be here negative and it must be here positive, and yeah. But this was just an attempt to give you a small overview of tubes, and this is my knowledge. So G2 to plus means resistance from anode to cathode goes down. G1 to 0 volts should in theory increase the resistance from anode to cathode, at least that's what Flose told me, and he really knows stuff about tubes. I mean, he has built his own amplifiers with tubes, and he knows how to... On a tube there's lots of electrons flowing around somehow in the tube. I don't really know how it works, but he also knows this stuff. Maybe I have some information wrong from him, but he sure knows his stuff. Okay, so that was my basic video about tubes. I hope you liked it. And this was just make another video. Okay.